Hello everyone. Today in this lecture number 4, property of soil, we will discuss few remaining property of soil which has which has not been discussed in the lecture number 2 and 3. So let us begin with. So as we know, the soil is having this kind of property, or soil can be represented by this kind of property: water content, void ratio, porosity, degree of saturation, air content, percentage, air voids, unit weight, specific gravity. So these property we have already discussed. So here, so here, we will discuss about this density index and relative compaction, which is remaining for this lecture. So let us begin with density index. This is also known as the relative density, and this is also known as the degree of denseness. So this the density index is uh, is representing the property of soil. That means it indicates the relative compactness of the cohesionless soil. It is represented by ID. Sometimes we will also represent it with RD, relative density. So this relative density is the ratio of difference between the maximum void ratio minus void ratio at the natural state, divided by difference between the maximum void ratio minus difference between the minimum void ratio. So from this, we can say this the relative density is the function of the void ratio. Now, if this void ratio at natural state is equal to the maximum void ratio, then relative density is equal to 0. So this represents the lowest state. If the void ratio at natural state is equal to the minimum void ratio, so ID is equal to 1. So this will represent the denseness state. So based on the different value of relative density, the degree of denseness are classified here. So if ID ranges from 0 to 15, then soil condition is very loose soil. If 15 to 35, then loose soil. If 35 to 65, then medium soil. If 65 to 85, then dense soil. If 85 to 100, then very dense soil. Now, this relative density can be expressed in terms of the dried unit weight using this expression. But before going to this expression, we will understand how we will attain this expression. So as we know, this void ratio is equal to volume of void divided by volume of solid. So multiply numerator and denominator by volume of the water. So this term is equal to representing some property of the soil, and the remaining term VW and VS can be written as the in terms of the weight and the unit weight of the water. So the VW is equal to WW by the gamma W, and VS is equal to WS by gamma S. So this volume of void divided by volume of water divided by volume of void is saturation. So this term can be written as 1 by S, and this will be the water content, and gamma S by gamma W is equal to GS, specific gravity. So if you will rearrange this term, you will get to know this expression. So from there, we have E is equal to WGS upon S. E is equal to void ratio, W is equal to water content, GS is equal to specific gravity, and S is the degree of saturation. Now, in the given three-phase system, let us understand the relationship between these parameters using this three-phase system diagram. So, assuming volume of solid is equal to 1. So, what will be the volume of void? So, E is equal to volume of void divided by volume of solid. So, Vs is equal to 1. So, E is equal to E is equal to volume of void. And we also know saturation. So saturation is equal to S is equal to VW upon VV. VV is equal to E. So VW is equal to S into E. So if you will having some difficulty in understanding this, you can go to lecture number 2 and 3. There, the basic definition of saturation and void ratio has been explained. Now, this is in terms of the volume. Now, let us understand these things in terms of the weight. So, volume of air is equal to 0. It is assumed to be 0. And then weight of water is equal to volume of water into unit weight. So, VW is equal to SE, then gamma W. So, from the expression of E is equal to WG by SR, we can write it W into GS into gamma W. Weight of solid is equal to volume of solid into weight, unit weight of solid. So 1 into this, we can write this term as like this. Now, this is some representation. We will use these things in coming content of this lecture. Now, here dry unit weight can be expressed as here we are talking about the two-phase system where solids and air are there. So gamma D is equal to Ws by V. The weight can be written as like this, and V total volume is equal to Vs by Vs plus Vw. Now here in the two-phase system, volume of solid is equal to 1. So volume of air is equal to E. Weight is 0, and this is the weight of the solid. So here we can express this weight as GS and gamma W, and this one will be 1, and volume of void is equal to E. So we have this expression. Now, if we will arrange the term of this expression, we have void ratio E is equal to GS gamma W upon gamma D minus 1. So here, if you will see this E relationship between void ratio and gamma D. So we will use this relationship to represent the ID in terms of the dry unit weight. So this E can be for E max, the gamma D will be gamma D max. For E minimum, gamma D minimum. For natural state, gamma D will be natural state. So just replace E value with this equation. Then we will have this kind of equation where this relative density can be expressed in terms of the dry unit weight. Now we also know this void ratio is the function of porosity, so we can express ID in terms of the porosity. So from this we will know. From this we have some kind of understand ID is the better indication of the denseness of soil than the void ratio and dry unit weight. So if you have void ratio and dry unit weight, and at the same time you have ID, so calculate the ID so that it will represent the better state of the soil. For the soil having similar shape and grain size characteristics, property causes will be different for different value of RD. So if the soil sample is having different value of RD, so for the same soil, so if we have high ID value, then denseness will be high, stability will be high, shear strength will be high, and permeability will be less. Now next term is the relative compaction. So what is relative compaction? So relative compaction indicates the relative compaction of both cohesive and the cohesionless soil. Means it is applicable for clay and sand also. So but this RD, relative density, is only applicable for the cohesionless soil. It can be expressed as gamma D by gamma D max. So we know this relationship of gamma D. Gamma D is inversely proportional to 1 plus E. So just replace this term. So in terms of the void ratio, relative compaction can be rewritten like that. Here is a relationship between the relative compaction and the relative density. So RC is equal to 80 plus 0.2 into ID. So there are a few other relationship between the property of soil. This we have discussed. So these are the other property which just you can recall for solving some numerical problem. Otherwise, if your basic understanding is clear, so it can be derived from there only. So here we will discuss about for uniformly graded soil. So if the soil is in loosest state of packing, then the maximum void is 91% and maximum porosity is 47%. And these particles are arranged, the nevertheless solids are arranged in the cubical area. In case of denseness state of packing, minimum void ratio is equal to 35% and my minimum porosity is 26%. And 12 never-holding solids are arranged here, and they are arranged in the hexagonal array. So for this lecture, uh, these are the only like detailing about these property, relative density and relative compaction. Apart from that, we have also seen the some kind of relationship between the property of the soil, which is helpful for solving the numerical examples. In the next slide, we will discuss about the consistency of soil. Here we will talk about the Atterberg limit, which are the liquid limit, plastic limit, and Seeger's limit. We will also see some applications which are included with this kind of subject or topic. So let's meet in the next lecture. Thank you.